Here's your warm-up for today, checking it. Make sure you've got your pen up to grade your work. The first thing is we're asked if it's direct, inverse, or neither. Direct means that if you divide y by x, they would equal the same thing. Inverse means if you multiply x times y, they would equal the same thing. Neither means neither of that would happen. Now to start cluing you in, if you want to look for direct or inverse, direct means that x and y both go up or both go down, so they do the same thing. Inverse means one goes up and one goes down. So if I look at our first example, my x's are increasing, so they're going up. My y's are decreasing, so they're going down. Which means if this has a relationship, it would be an inverse, since one goes up and one goes down. To check that, we see do x times y equal the same thing every time. So 2 times 18, that's 36. So they all have to equal 36 for it to be inverse. If they don't, then this doesn't have a proportional relationship. 3 times 12 is also 36. 4 times 9 is also 36. So since they're all the same, this is inverse. It then says if it has a relationship, which means inverse or direct, to write what k is, and k is the 36. The second one, x and y. So looking at my x's, they're going up again. Looking at the y's, they're also going up. So if this has a relationship, it would be direct. To check if it's direct, we divide to find that value. So 4 divided by 1 is 4. 8 divided by 2 is also 4, so far so good. 12 divided by 3 is also 4. So this one's direct with the k value of 4. Number 2, this will hopefully clear up any confusion you had with the words varies, jointly, inverse, and direct. Now, to write the function, and notice all these are variables, so we're just learning when do I multiply and when do I divide. So we start with A. Varies is going to mean two things. It means that's where it equals, and because it's a variation, that means we have to insert in the letter k. Check your work. There's no k in here, but because of the word varies, that means we have to insert one. Now our next keyword is jointly. Jointly means we're going to multiply, and you're going to have two or more things that you're multiplying by. In this case, we're multiplying by b and c. So b and c. The next comes up is inversely. Inversely means we have a division problem, and we're dividing by d. So A equals k times b times c all over d. Number 3 says y varies. So I know it's going to be y equals, and I insert in k. The first keyword is directly. That means to multiply, but you're only going to multiply by one thing, where jointly you multiply by 2 or more. So we're multiplying by x. And then inversely, again, that means to divide, and in this case, we're dividing by w. So those are your keywords: jointly, inversely, directly, and then varies, which means to insert in your k value. So if that was confusing to you, hopefully this warm-up helps you clear it up. Here are your homework answers from last night. We'll go over these a little bit in detail. Number 1, your x values were going up. Your k values or your y values were going down. So to find the k, you should have multiplied each row, and each time it gave you 0.3x. To write an equation, remember inverse is y equals k over x. So you insert the k into the fraction. Direct means that they were both going up, or they both could have been going down. In this case, both up. To find that k value, it's dividing, so you divide 3 by 1, which is 3, 6 by 2, which is 3, 15 by 5, which is 3, 18 by 6, which is also 3. So there's your 3. Direct, we write the equation as y equals k times x, and you insert in the 3 for k. Number 3, the x values went up, the y values went up, so if it had a relationship, it would have been direct, But 1 divided by 0, well, that's impossible. You're not allowed to divide by 0. So pretty much right away you know it's neither. If you wanted to, you could check 5 divided by 2 is 2.5, which is not the same thing as 7 divided by 4. So that's why it's neither. The next section, x and y vary inversely. When we have the words vary inversely, I know this is a little bit different. To find the k value, because we're not inserting k and we're literally finding it, you have to multiply them together. So 2 times negative 4 gives you a k value of negative 8. So you plug k into the inverse equation, which is k over x, and then it says to find y when x is 10. So we replace x with 10, and then in this case, either of these answers is fine. Number 5, we multiplied them together to find our k value, and then inserted in 10 for x. So 9/10 or 0.9, and then the same exact thing for number 6. 7 and 8 is where we see those words, and 9, that we worked on the last 2 questions on the warm-up. Number 7, it said the amount of time, so that's your t, varies directly. So right away we know equals and k. Directly means we're going to multiply with the length, so that's the L, and inversely means we're going to divide by S. It then said 25 students, so that was your S. Clean up 5 miles, that was your X. And the time was 2 hours, that was your 2. And that allowed you to find K. We then take K in, times the 34, and divide by the number of students, and that gives you the time is 4 hours. 8 and 9 is exactly like the warm-up, but then you actually plug in numbers to find K and then to find what you're missing. So 8, Z varies inversely, so Z equals in K. Inversely with X means divide by X. Directly with Y means to multiply by Y. It then told us X was 5, Y was 10, Z was 2. And this tells us this information in order to find K. So we plug it in to get our K value, and then we plug in these values with K in order to find Z. Number 9, it threw in the square of X, which means X squared, but other than that, it followed the exact same steps as number 8. If you need to, pause this to check your 7, 8, and 9. Otherwise, pass out the notes for today, and we're going to start with more introducing chapter 5. Your notes should state Intro to Chapter 5, Rational Functions and Their Graphs is what we're looking at today. A rational function is going to be the quotient of 2 polynomial functions. So polynomial functions are your monomials, binomials, trinomials, and so on. So it's one divided by another. A continuous graph is a graph that pretty much continues. So there are no jumps, breaks, or holes. So that means if you are drawing it, you can draw the graph without ever taking your pencil from the paper. That's pretty much every graph you've drawn at this point, to be honest. The next type of graph is what we call a discontinuous graph, and that is the graphs that we're going to be focusing on more. It's a graph with one or more points of discontinuity. And yes, we will clear that up. Points of discontinuity mean somewhere that the graph takes a break. So the line doesn't connect the entire time, there's a little space between them. So a point of discontinuity, how we find that is if you have a point with an x value that makes your denominator 0. You're not allowed to have a denominator of 0. So you can't have a point on the graph where that exists. And when that happens, it means that your line jumps over or has a break or what we call a hole. There are two types of these points. They're what we call removable or non-removable. Removable means that you're going to be canceling, which means you've got something that's the same on top and bottom of a fraction. And when that cancels, we have a hole. So on a sketch, it kind of looks like this. There's your line, there's a hole, and then your line keeps on going. Non-removable means that your numerator or your denominator will not cancel. And this is what we worked on the last chapter. When they don't cancel and it's non-removable, that means we're going to have an asymptote. And we learned in the last chapter, an asymptote means that our line keeps going to a certain point, but it never actually touches it. And we had that with our exponential functions. So to find these points of discontinuity, we've got to determine which x values will make the denominator equal to 0. And once again, we're going to be factoring here. So since this is a fraction, we have to make sure we factor the numerator and the denominator. So we'll be using our Santa hat method. Then we're going to set each factor of just the denominator because we don't care if the numerator is equal to 0. We only care about the denominator. And solve for x. And we've done this before. So all that's happening here is we're placing our skills into a new section. And then we determine if it's a hole or if it's an asymptote. So we're going to do a couple of examples together, practice our factoring. So our first example, y equals x plus 3 over x squared minus 4x plus 3. Well, factoring means we either have something in common or we have an exponent that we need to break down. So if I look at my numerator, x plus 3, well, there's no GCF there. X doesn't have an exponent, which means I can't factor x plus 3, so I just bring that down. Now the denominator, x squared minus 4x plus 3, trinomials we can typically factor. So we're going to use our Santa hat here. So we've got 1x squared times 3, just 3, and we're looking for factors that add up to the middle, which is negative 4. So they have to multiply to 3, but add to a negative 4. So that means they're both going to be negative. And hopefully you thought of negative 3 times negative 1. Since our x squared value is 1, this is the easy or the shortcut factoring. So we can immediately put our two parentheses. And we have x minus 3, or minus 1 if you want to put that first, and x minus 1. So that's step 1, we factored. Now we take the denominator, and we've got two parentheses in the denominator, and we're going to set them both equal to 0. So x minus 3 equals 0, and x minus 1 equals 0. And now we solve for x. Hopefully you're recognizing all this that we've done before. So we would add 3. So x equals 3, or maybe you caught on to that right at the beginning. That's fine too. And then x minus 1, we would add 1. So x would equal 1. Now we have to determine which of these is a whole and which of these is an asymptote. So I look at the beginning and I say, okay, I have an x plus 3 on top. Is there any of these parentheses that will cancel out, which means they'd be identical? The answer to that is no, because these aren't the same. These aren't the same, so nothing cancels. And when it doesn't cancel, then we have asymptotes. So at x equals 3 and x equals 1, that's where our asymptotes would be. So let's look at the next example we're going to do together before you try a few on your own. So our next one, if I look at the numerator, that one's going to have to be factored. So I've got 1 times -4, which is -4, and they have to add up to factors of -3. Well, to multiply to a negative, one has to be positive, one has to be negative. I'm either looking at 4 times 1 or 2 times 2, and the only way of those to get a 3 is the 4 times 1. So I have to figure out, is the 4 negative or is the 1 negative? And since the 3 is negative, the bigger one has to be negative. So -4 times 1. So my numerator is going to become x minus 4 and x plus 1. And again, it doesn't matter if you were to write the x plus 1 first. Now, the denominator, we have x squared minus 16. This is one of those special binomials. It does not have anything in common, but x squared minus 16 is what we refer to as that difference of squares. So one parenthesis will be x minus 4, and the other one will be x plus 4. So now we only worry about the denominator at this point. So I set each of those equal to 0. So x equals 4 or x equals -4. Now I determine if these are wholes, asymptotes, or one of each. And remember, to determine that, we look back at the fraction and I look for anything that would cancel, which means it's the same on top and on bottom. Well, that's the x minus 4's. So the x minus 4 is a whole because it cancels. So I'm going to write a whole underneath this. X plus 4 would not cancel, so when it doesn't cancel, it's an asymptote. And these are your answers. So now go ahead. We're going to actually do the next few tried together, and then there's some that you'll practice on your own here. So I look at my fraction x minus 9. Well, there's nothing to factor there. And then I have x squared plus 1. Now, that's not the same as our x squared minus 16 because it's a plus instead of a minus. So I can't factor this. However, I still need to set my denominator equal to 0. So I go x squared plus 1 equals 0. Subtract 1. X squared equals -1. So if I were to take the square root of this to get x by itself, can I take the square root of a negative? Well, the square root of a negative means I'd have an imaginary number, and I don't have imaginary numbers on a graph. So this won't happen because of that imaginary part, which means we don't have any wholes or asymptotes, so there is no discontinuity. So that one was kind of a special case. We're going to skip these 3 U-tries for now. And then you'll see these problems at the end of class if there's time. If not, you can always go onto YouTube and check these 3 problems and make sure you're doing things correctly. We'll practice vertical asymptotes, but we're going to practice it with the next section as well. Now, when we worked on the previous problems, we were finding vertical asymptotes. Now we also have horizontal asymptotes, and we find them differently. Horizontal asymptotes, we have to identify degrees. So step 1 is we need to identify the degree of the numerator and denominator, and we have 3 cases. The first case is if the numerator and denominator have the same degree. If that happens, then we're going to take our leading coefficient of the numerator and divide it by the leading coefficient of the denominator. And we'll go over these. If the degree is bigger on the bottom or the denominator, then your answer is always y equals 0. If the numerator has a higher degree than the denominator, then the answer is simply no asymptote. So the only one that really changes is if they have the same degree. So we're going to look at 3 together, and then you're going to have some to practice on your own. So the first example, first of all, I'm going to fill in visible exponents. So this x has a 1, and so does this one. Well, those are the only exponents, so those are my degrees. So this has a degree of 1. This has a degree of 1. So the degrees are the same. So I look at my 3 cases, and we're looking at case number 1. So I'm going to put a case 1 here just so I know where to go back and look at. Case number 1 says we take the leading coefficient of the numerator and the leading coefficient of the denominator. Well, the leading coefficient of the numerator is 2. The leading coefficient of the numerator is 2. Of the denominator is just an x. Well, we always know there's an invisible 1 there. So it's 2 over 1, which is 2. So our horizontal asymptote is y equals 2. Now another difference here is horizontal is y equals, vertical is x equals. And think about that. If you graph a y equals line, it's always a horizontal line, goes straight across. And if you graph x equals a number, it's a vertical line. It goes up and down. Second example, in the numerator, the only variable, because remember, degrees only come from variables, is an x. So that has an exponent of 1. So that's my degree. In the denominator, the degree is 2. So 1 on top, 2 on the bottom. So I'm looking at the fact that the degree is higher on the bottom, so bigger on bottom. And if you look at your 3 cases, we're talking about case 2. And whenever the degree is bigger on the bottom, our horizontal asymptote is y equals 0, every time. Example 3. So if I look at our numerator, we have x squared. So that has a degree of 2. Denominator, we only have 2x, and that has an invisible exponent of 1. So I've got a 2 on top and a 1 on the bottom, so it's bigger on top. So we're looking at case 3. And case 3 says whenever the degree is bigger on top, the answer is simply no asymptote. So now we're going to put what we've learned previously with the vertical and the horizontal together when we do the next ones. So here are those three U-try problems from vertical asymptotes. If you had a chance to do these, then you'll be able to check them. If not, again, you can go home, practice them, and check them to make sure you're doing things correctly. So pause this until you're ready to check your answers for these three problems. All right, our first U-try, again, vertical asymptotes, we're looking for factoring. So on the numerator, there's nothing to factor with 4x. However, when I look at my x cubed minus 4x, the first thing I can do is pull out what they have in common, which is an x. So if I take an x away from each, I have an x squared minus 4 now. Well, I can still factor x squared minus 4. So I'm going to rewrite the numerator, bring down that first x. X squared minus 4 becomes x plus 2 and x minus 2, because it's the difference of squares. So now in my denominator, I've got three things to set equal to 0. I have x equals 0, x plus 2 equals 0, and x minus 2 equals 0. Well, this one's already solved for. X equals 0. X plus 2 equals 0 turns into x equals negative 2. And x minus 2 equals 0 turns into x equals 2. So now I have to determine my three answers here, which ones are wholes and which ones are asymptotes. So I go back to where everything's been factored and I look for something to cancel. Well, the only thing that would cancel is this x with this x, which means this is a whole. And the other two then are vertical asymptotes, and I'm going to call them VAs. So there's your answer for the first U-try. Going over to the second U-try, x squared plus x over x plus 1. The numerator can be factored by pulling out what's in common. They both have an x. So when I take an x away from each, I get x plus, now if I take an x from x, that's going to leave me with a 1 over x plus 1. To find your wholes and asymptotes, remember you only focus on the denominator. So we go x plus 1 equals 0, which means x equals negative 1. To label that a whole or an asymptote, we go back and we look to see if it would cancel. Well, there is an x plus 1 on top, which means this would cancel with this, and anytime it cancels, we have a whole. Last U-try, it's actually already been factored for you, so you don't have to worry about that. So we're just going to set your denominator equal to 0. So x plus 3 equals 0. X minus 2 equals 0. So this means x equals negative 3 and x equals positive 2. Well, would anything cancel here? And the answer to that is no, because to cancel you'd have to have an x plus 6 and we don't. So that means these are both vertical asymptotes. Now, these are just under the horizontal, but we're going to go ahead and practice both. So we're going to find vertical and horizontal. So you might want to write that above these problems. So we're going to do the first one together to show you. The first thing is I'm going to find horizontal, because horizontal is before you factor. So I'm going to do this in red. So horizontal, we look at the degrees. So the highest degree in the first U-try is the 2. The highest degree in the numerator is a 1. So it's bigger on top. So look at your three cases. And the one that's bigger on top means there's no asymptote. So I'm going to put HA for horizontal asymptote, and there is no asymptote. So now I'm going to work on the vertical part for wholes and asymptotes, which means I have to factor. And I'm going to do this in blue. So my numerator, I'm going to go 1 times -3, which is -3, and I'm wanting them to add up to a +2. So factors of -3 that add up to 2 would be 3 times -1. So my numerator is going to become x plus 3 and x minus 1. The denominator can't be factored, so it's just x minus 2. So we set only the denominator. Yes, we factored the numerator, but that's just to determine if something will cancel. So we take just the denominator, x minus 2 equals 0. So x equals 2. And now I need to determine if that's a whole or a vertical asymptote. Well, will x minus 2 cancel with anything in the numerator? The answer to that is no. So x equals 2 is a vertical asymptote. So I'm just going to label it VA. So that's how you find both horizontal and vertical. And it all depends on your directions, if you have to do both or just one of them. So go ahead and try the next 2 U-tries. If you get them done and you have time, you could go ahead and practice the ones on the previous U-tries that we skipped over. And then hopefully you wrote the answers down when I showed them to you. If not, you can go home and check them on YouTube. So pause this until you're ready to check these 2 U-tries. So for our first U-try, again, horizontal asymptotes, check those first. So our degree in the numerator is a 1. The degree in the denominator is a 1 as well. Whenever the degree is the same, remember it's the division of the leading coefficients. Well, the leading coefficient on top is a -2. The leading coefficient on the bottom is a 1. So -2 over 1 is y equals -2 is our horizontal asymptote. So now we work on this with the vertical. So I'm going to rewrite this. Now for the next one with the vertical asymptote, the top part actually could be factored because they have something in common. They have a 2 in common, or you could even think of it as a -2. If you didn't do that, it is okay. It doesn't affect this problem, but it's best to work on factoring as much as possible. So I'm going to take a -2 out of the numerator. So -2x divided by -2 is a positive x. However, if I do a positive 6 and divide it by -2, that turns into a -3. And it's over x minus 5. Now remember, with vertical asymptotes, we only care about your denominator. So x minus 5, set it equal to 0. So x equals 5. Now I check to see, could something cancel here? Because if it cancels, it's a whole. If it doesn't cancel, it's a vertical asymptote. Well, x minus 5 and x minus 3 aren't going to cancel. So that means this is a vertical asymptote. Okay, the last U-try. Again, first with horizontal. On top, we have a degree of 1. On bottom, we have a degree of 2. When the bottom is bigger than the top, that's case number 2, and it has always a y equals 0 as your horizontal asymptote every time the bottom is bigger. Now looking for vertical, well, x minus 1 on top can't be factored. If I factor the bottom, I've got 1 times 4, and I need that to add up to a 4 as well. So the factors of 4 that add up to 4 would be 2 times 2. So my 2 denominators, parentheses in the denominator, would be x plus 2 and x plus 2. Now remember, we only set the denominators equal to 0 for vertical. Do I need to set both parentheses equal to 0? No, because they're the same parentheses. So I just need to do one. So if x plus 2 equals 0, that means x equals negative 2. I look back here. Would anything cancel from the top and the bottom? The answer is no, which means this is a vertical asymptote.